So today we're working on a linear algebra problem. We have the set S, which is equal to, it's got 3 elements, 1 minus x, comma x squared, and comma 3x. And this is, we're going to be considering it as a subset of P2, which is the set of all polynomials of degree 2 or less in R. And we're asked to use the Gram Schmidt process to transform the set into an orthogonal set using inner product fg equal to the integral that goes from -1 to 1 of f of x g of x dx. Okay, and f of x and g of x are in P2. So we're going to use the Gram Schmidt process, and if you ever used it, or sorry, haven't used it, it can be kind of tedious. So just bear that in mind when you're doing this. It might say, yeah, it's kind of long. It is, okay. For the most part, unless you have like 2 vectors here, but usually it's going to take some time. And the Gram Schmidt process, it's based like an algorithm. And just to start off with, we're going to have a set of vectors, u1, u2, un, as you see right here, which are linearly independent, okay, which was the case with our vectors. And what we're going to do is we're going to turn the set into this set, v1, v2, comma vn, where all the vectors are orthogonal to each other. So if you take the inner product with v1 and v2, it's equal to 0. v2 with like v3, it's going to equal 0, okay? And the way we define these vectors, v1, v2, etc., is how we go about getting our orthogonal set. So v1 is going to be always just the first vector in the set. So just u1. Now for v2, this is where the arithmetic starts to get in here. It's going to be u2 minus the projection vector of u2 onto v1. And yeah, that formula for the projection of u2 onto v1 is given by inner product of u2 v1 over the magnitude of v1 squared times the vector v1. Okay. So we're going to have that as our second vector, and this process goes on. We're only going to go up to v3. v3 is equal to u3 minus the projection of u3 onto v1 minus the projection of u3 onto v2. And with formulas, it's going to be u3 minus the inner product of u3 and v1 over magnitude of v1 squared v1, and then minus inner product of u3 v2 over v2 squared v2. Okay, and what I'm just writing down here is just, I'm just saying, yeah, it goes on and on here. You can have the projections, you can have more vectors than just 3. Obviously, you can have as many as you want here. All right, and finally, often it is the case that with these types of questions, you're asked to find an orthonormal set. An orthonormal set basically is a set which is orthogonal and has a length of 1, has a magnitude of 1 or norm of 1. And the way you do that is by taking the vectors themselves and dividing by their magnitudes. Okay, so I wanted to make it. Now that's not the point, more of the orthogonal vectors, but just information there. So we have our set, and again, I wrote what I'm going to need, and I'm going to start off with v1. So let me start down here. v1 is equal to 1 minus x. And v2, that's what we have here, is going to equal u2, which is the x squared, minus the inner product of u2 and v1 over the magnitude of v1 squared times v1. In other words, x2 minus the inner product of 1 minus x and x squared over the magnitude of 1 minus x squared times 1 minus x. All right, now for me, the main concern is figuring out this inner product with the 1 minus x and the x squared, and we're going to take an integral for that. So whenever you're doing these problems, the inner product must be defined, by the way, for you. This case is in terms of an integral. So we're going to go integrate from -1 to 1. And yeah, just some algebra that you got to do to integrate, and I won't do that here, but you get 2/3 out of the whole thing. Now so that's what this part entails. right here. This is 2/3 highlighted. And now I'm going to calculate what you see right below it. It's going to be the magnitude of 1 minus x squared. So, and we go over here real quick. Recall, you take the magnitude of something, it's the square root of the inner product of the vector with itself. So the magnitude squared is the inner product of the vector with itself. So the magnitude of 1 minus x squared is going to equal the integral from -1 to 1 of 1 minus x all squared. That gives us 8/3. And just writing here, this is being redundant, but just kind of following along with the formula, writing it down again. I plugged in my values that I got for those inner products, 2/3 and 8/3, plugged them in and did some arithmetic, and this is what my V2 came out to. So you got x squared plus 1/4 x minus 1/4, and that would be my V2. My next vector is V3, which is U3 minus the inner product of U3 V1 divided by magnitude of V1 squared times V1 minus the inner product of U3 and V2 over the magnitude of V2 squared times V2. And I just plug things in where they need to be, okay? And one thing to note here is that, yeah, you got a little bit of a formula, which is when you're figuring out Vn, it's equal to U sub n minus U, like the inner product of U sub n with each of the other V's before it. So in this case, V1 and V2 divided by those magnitudes times those vectors, okay? And so I plugged these in, and all I did here was computed some more integrals. So I had to compute the inner product of the 3x and the 1 minus x. That came out to be a -2. Then I went ahead and computed the inner product of the 3x and the x squared plus 1/4 x minus 1/4. And that gave me a half, so that's right here. Again, just integration. And finally, the magnitude of x squared plus 1/4 x minus 1/4 all squared. That can amount to 7/30. As you can see, you have that magnitude of 1 minus x squared there. I don't need to compute that, we already did. So that just comes along for the ride. And yeah, and I just plugged in those numbers correspondingly from all this stuff. And that came out to be this. And that came out to be that right there. And yeah, so it's just a bunch of tedious arithmetic. Once you get to the third vector, people just kind of start to get frustrated. So do I sometimes with this process. And yeah, it's just a bunch of algebra until you come to the end with this vector V3. And there you go. These are what you see in blue, 1 minus x, comma, x squared plus 1/4 x minus 1/4. And then minus 15/7 x squared plus 12/7 x plus 9/7. That is your list of orthogonal vectors. If you take the inner product of any of these vectors with the other one, any of the other ones, the inner product is going to be 0. Okay. One last thing here is if you wanted to make an orthonormal set, have it to be a magnitude of 1, you would take each vector and divide it by their magnitudes. And their magnitudes basically would just, we had said earlier, it's the square root of the inner product with itself. So it's the square root of, you would get 3/8, square root of 2/37, and 7/24 here, okay? So that's what it would come out to. And what else was I gonna say? That's how this process works out. So yeah, kind of tedious, but yeah, pretty much doable, okay? All right, thank you for your time.